Hello dear students, today I will discuss about plane, three-dimensional geometry chapter, equation of plane. Because in this chapter there are two topics, straight line, 3D straight line and plane. So just like line, plane can be uniquely determined in three cases. First case is normal form, second case is passing through a point and plane is perpendicular to a given direction, and third is passing through three non-collinear points. So first of all, plane in normal form. Plane in normal form. Okay, first plane, equation of plane, normal. Equation means, in equation there will be a arbitrary vector, position vector of a point, means a variable point. If variable point is xyz, then its position vector we can write xi yj z plus xi plus yj plus zk. Similarly, if arbitrary point xyz, the equation will be in Cartesian form, in terms of xyz, and other will be constant. And in vector form, vector r equals to xi plus yj plus zk, that will be the arbitrary vector, which makes from Cartesian coordinate, just like xi plus yj plus zk, and that will satisfy the equation of plane. Means first is normal form. Normal form means if we are given perpendicular distance from origin to the plane, then we can find the equation of plane. Just like this, suppose we are having, this is what? Our frame, x-axis, y-axis, z-axis. This is our 3D frame. This is origin. Clear? Now, this is 3D space, means this blank space. Okay. So this is plane, and lower plane is this. Okay. So we can consider like plane like this, like this, like this, like this, like this, like this. Means plane not parallel to this, inclination plane, or maybe parallel. If this is parallel plane to this plane, then this will intersect. This is x-axis, this is y-axis, this is z-axis, then y-axis intersecting with y-axis. So if inclination, then this plane will intersect 3 axes. So suppose our general plane intersecting 3, this is plane. Okay, any of the plane. Suppose this is a plane. and from means this is a plane. Clear? And distance from origin, perpendicular distance, is this. This is a point. This is perpendicular distance. Distance is d. Okay? And only we know perpendicular distance from the origin. Plane, perpendicular distance. This is point on plane. Suppose this is n. And take an arbitrary point on the plane. On the plane, anywhere, take an arbitrary point. Suppose this is an arbitrary point. P and x, y, z. This is the Cartesian coordinate of the plane. Point, Cartesian coordinate in 3D. This is point, Cartesian coordinate. Because we will study about Cartesian and vector form both simultaneously, so that's why. Now, this is what? Position vector. This is position vector. If we draw like this position vector of P. Suppose this is denoted by R vector. This is denoted by R vector. So R can be written xi plus yj plus zk. And now this is point N in plane and this is point P. So NP. If we join NP, then this NP lie on the plane. NP lie on the plane. Okay? And ON is perpendicular. So NP perpendicular ON. Now, if unit vector perpendicular to the unit vector in this direction, ON direction, this perpendicular direction is n cap. Suppose n cap is a perpendicular unit vector to the direction n, ON direction. Then in this direction, in the direction of ON, okay, n cap in this direction, a unit vector is n cap. Suppose, then the vector ON will be what? Vector ON will be d into n cap, and np equals to vector np equals to np. Vector np equals to, we can write vector op minus on, that is r minus dn cap. Okay, this is equals to this minus this. So you can write now, this is equals to this plus this. So this is equals to this minus this. Here ON perpendicular NP. Here ON perpendicular NP implies ON dot NP is equals to 0. That is NP dot, we can write NP dot ON, something. NP means vector R minus D n cap dot ON means D n cap equals to 0 vector. So this can be simplified just like this. D constant value, scalar value. So D can be taken outside and D is not equals to 0. So we can write R cap minus D n cap dot n cap equals to 0. D is not equals to 0. So here just do the dot product. We can get r dot n cap minus d dot d into n cap. N cap equals to 0. So n cap dot n cap 1. So r dot n cap d is transferred to right hand side. So this is our normal form of plane. Normal form of plane. R means position vector of a point, arbitrary point on the plane, xi plus yj plus z. And n cap is perpendicular. N cap is a unit vector along the perpendicular distance of plane from the origin. Perpendicular distance of the plane from origin. Along this, n cap is a unit vector and d is perpendicular distance. Okay, this is perpendicular distance. When this is n cap. Similarly, second form. This is normal form. What? Vector r dot n cap equals to d. Okay, second form is this is a vector form of normal form. Okay. Now Cartesian form. What will be the Cartesian form? Cartesian form can be. How can you get Cartesian form? Cartesian form can get. First of all, suppose this vector, unit vector means unit vector can be written as a component form xi plus yj plus zk. This is a unit vector. Its components are its direction cosine. That is, if direction cosines of this vector, a unit vector element, then we can write li plus mj plus nk. If suppose we are taking not a unit vector, a pure vector, then its direction n can be written as like this, n1, or just write ai plus b j plus c k. That is abc are a scalar component of a vector. If this vector is perpendicular to plane, that is normal to the vector. Normal direction. Normal direction means what? Plane, a direction which is perpendicular to the plane. That is the normal direction. And a vector having a scalar component ABC can be written like this. If this vector is perpendicular to the plane, then this is normal to the plane. Normal may be anywhere in the plane. Whenever it passes through origin, that is the condition here. Now, if in this direction we find unit vector, we can find unit vector. How can we find unit vector? Unit vector can be found if it is divided by its modulus, that is root of a square plus b square plus c square root of a square b square b square c square, and everywhere we will get direction cosine. So this is direction cosine for unit vector. Okay. So now here r means what? Xi plus yj plus zk. If r is the point, and n cap means what? Li plus mj plus nk. Because to d it is distance perpendicular. So dot product you can take Lx plus my plus nz equals to d. So this is normal form. Cartesian normal form. Cartesian normal form. Clear? Or this is vector. This is vector form. Here element are what? Direction cosine of normal. When we write the equation of plane as a normal form, then we can say that D is perpendicular distance of plane from origin. Clear? From here, just we can say that if this is not unit vector, simple vector, then from here we can find, because these are the direction of cosine, if it's lower, we write like in this form, then we can get what? Ax plus by plus cz upon root of this a square, sum of a square plus b square plus c square, and that will be multiplied to here. That will be not normal form. That is ax plus by plus cz plus d dash, that has d will d dash equals to, or we can write also in capital D on other form this. So this, or just like equals to d dash. This is also equation of what? Plane. Equation of plane, not in normal form. This is equation of plane, not in normal form. Okay. Okay, this is not, if we take here element in place of element ABC, then we can get like this. This is equation of plane in vector form. Okay, where ABC, where plane in vector form, where here n is normal to the plane, not unit vector. ABC. So ABC are the direction ratios of this. So where ABC are direction ratios of normal to plane. So remember it, okay? Whenever we have a plane in just like this, x plus by plus cz equals to d, not this, not with direction cosine, not with unit vector, like only normal vector. Only normal vector means its direction cosines are ABC. So these are the what? Direction ratios of normal to plane. If this is equation of plane. For writing it in terms as a normal form, this is not normal form. Okay, equation of plane is this. General. Clear? And for making normal form, just you have to divide this by root over a square plus b square plus c square, and then it will convert like this. Here also divide, that will be the direction cosine. Here this by root over this, that is equal to d. D is the perpendicular distance from origin. Perpendicular distance from origin of plane. Okay. So this general form, this is normal form. Okay. So remember this formula, very important. What is n? What is n cap? What is normal form in vector form, in Cartesian form, or this is general form. It can be transferred to here, just reduced to like this by dividing it root over, what? A square plus b square plus c square. A by this x plus b by this plus y plus c by this root summation a square z equals to d dash by root over a summation a square. This will be d, or this will be n, this will be m, this will be l. So lx plus my plus nz equals to d. Okay, so remember this formula. This is the first form of plane, equation of plane. Now, second form is what? Whenever plane passing through a point and having perpendicular to a direction, perpendicular to a given direction. Okay, then how can we write the equation of plane? The equation of plane can be found in terms of Cartesian form from vector form by putting what? R equals to xi plus yj plus zk and taking dot product. Okay, so here second form is equation of a plane perpendicular to a given direction and passing through a point. So just one by one. First, normal form. What? Vector r dot n cap equals to d lx plus my plus nz equals to d ax plus by plus cz equals to d dash. First point. Okay. This is general form. Now, suppose this is our x-axis, y-axis, z-axis, and plane is this. This is a plane, okay, and this is a direction. Vector n means a plane, a vector perpendicular to the plane. Plane perpendicular to vector is n vector, and plane passing through a point A. Passing through a point A. Plane passing through a point A. Okay? A. Maybe its coordinate x1, y1, z1. And we have to find the equation of plane. Plane passing through a point x1, y1, z1, and we are given a perpendicular direction to the plane, that is normal to the plane, called normal to the plane. And for finding equation, just take one arbitrary point in anywhere on the plane, that is P. Okay, and its coordinates suppose x, y, z. Then this is O, OP, a vector, also OA, a vector. We can join it. So just like this. Now, by vector addition we know AP equals to what? If its position vector is denoted by R, suppose its position vector is denoted by R vector, or its position vector is denoted by A vector. It is position vector R, position vector A. Then AP will be what? AP will be R minus A. So here, what will be the situation? AP on the plane, and this is perpendicular to N cap. Here, AP perpendicular to N vector implies AP dot vector N equals to 0. Dot product. Here, AP means vector R minus vector A dot N cap equals to 0. Okay, so this is vector form. Vector form, plane passing through plane passing through a point A, x1, y1, z1 and perpendicular to vector A. This is vector form. Passing through this point, whose position vector is A, vector, and then, not N cap, N vector. So vector N can be written, just suppose AX, AI plus B, Z plus C, K. If vector is this and R is R, xi plus yj plus zk, and A, x1, y1, z1, then also A can be written. So we are having just like this, R equals to xi plus yj plus zk, vector A equals to x1 I plus x y1 z plus z1 k, and n is ai plus bj plus ck, this, and put all the value here, then we can get Cartesian form. So here R means xi plus yj plus zk minus, this is R, minus A means x1i plus xy1j plus z1k, this is dot, this dot A I plus bj plus c k equals to 0. So here we can see that what? This minus this means x minus x1 I, y minus y1 z, z minus z1 k, this dot, this ai bj ck equals to 0. Now use dot product, then we can write a x minus x1 b y minus y1 c z minus z1 equals to 0. This is the equation of plane passing through a point x1 y1 z1, and ABC are the direction ratios of normal to the plane. Okay, so remember this formula. A, we can write also here using capital ABC here, capital ABC, capital ABC. So just like capital A, capital B, capital C, then third, A x minus x1 plus B y minus y1 plus c z minus z1 equals to 0. Passing through the point x1, y1, z1, and ABC are the direction ratios of normal to the plane. Clear? So this is second formula, that is Cartesian formula, and that is vector formula. Vector formula is r minus a dot n is equals to 0. Okay, this is Cartesian, this is vector formula. Vector give easy approach, okay, and short writing. So this is the form of equation of plane passing through what? A point, and plane is perpendicular to a given vector, that is vector n. Okay, so remember this formula. And third format is equation of plane passing through three non-collinear points. Here non-collinearity is very important, because in space if we have 2 points, then they are linear very easily, you can see. If 3 points are there, suppose 2 points are in a plane, and third point may not be lie on the plane or in the line, because this is line and here is a point, that's not non-collinear. So 3 non-collinear points, 1 point, 2 point, 3 point. If 3 points are collinear, suppose we are having 1 point, 2 point, 3 point, and then plane passing through this point may be infinitely point, because just like this, point here, linear point, not collinear, not here, linear point. So we can make a plane like this, also 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 like this. There are infinitely many planes. Will be infinitely many planes. Okay? So, for unity determined a plane through 3 points, so points must be non-collinear points. Non-collinear points means they should not be lie on a line. Collinear, non-collinear points. So here is a point, here is a point, and another point is here. Then we can find we can determine a uniquely a plane. Just like this, suppose we are having like this, x-axis, y-axis, z-axis. We have a plane, suppose this is our plane. This is our plane. Then, if one point is this, another point is this, another point is this, so this point A, this is point B, this is point C. Okay, x1, y1, z1, x2, y2, z2, this is x3, y3, z3 in Cartesian form. If we consider vector form, then this 3 point having position vector as like this. This is origin. OA position vector A, OB position vector B, OC position vector C, and Cartesian coordinate are like this. These 3 points lie on the plane. 3 points. Then we can see that AB and and AC. This. So B minus A and C minus is there, na? This AB vector and this AC vector, because all the points lie on the plane. So AB, AC, both vectors lie on the plane. So these two vectors lie on plane, and we know the cross product of two vectors gives a vector perpendicular to both the vectors. That is, if these two vectors lie on this plane, then AB cross AC will be this vector. Give the direction like this. Clear? And here, just let P be an arbitrary point for finding equation of plane. We require a point. Let a arbitrary point on the plane, that is P, having coordinate x, y, z, arbitrary point. And its position vector will be what? We know as is a r. Then P is also on the plane and A is also on the plane. AP, that is this. This vector, AP vector, this lie on the plane, and AB cross AC is perpendicular to the plane. So AP and AB cross AC are perpendicular. Here, AP dot AB cross AC equals to 0. Very clear? AP means this, and this cross product is perpendicular to the plane, so this is equals to 0. So we can write like this in vector form. AP means R minus A dot, just write like B minus A cross C minus A. This is a vector, this is a vector, dot product is this, equals to 0. So this is vector form. This is vector form of plane passing through three non-collinear linear points. Non-collinear points. Vector form of plane can be written like this. Vector form of plane passing through three non-collinear points that are A, B, C, whose position vector is A, B, C, and R is the arbitrary point on the plane. So this is vector form. And Cartesian form for A, B, C, these are the Cartesian coordinate. So It can be, because this is actually a triple product and it can be solved by solving a determinant. So note down it. Okay. Here, Cartesian form. What is Cartesian form? Cartesian form is very simple. Just like we have to solve x minus x1, y minus y1, z minus z1. Here, x2 minus x1, y2 minus y1, z2 minus z1. Here, x3 minus x1, y3 minus y1, z3 minus z1. Okay, so this is equals to 0. This determinant gives, which give equation of plane passing through x1, y1, z1, x2, y2, z2, and x3, y3, z3. Okay, this determinant is equals to 0. Just you have to solve here x1, z1, x2, y2, z2, x3, y3, z3. They are given points. Plane passing through these three non-collinear points is given by this as Cartesian equation. This is vector equation. Okay, so these are the points. How can we write the equation of plane in normal form? Also normal form, and then passing through one point and perpendicular to a direction, and these are the passing through 3 points. So how can you write the equation of plane? Just use this formula, okay, for writing. Now take some questions from exercise 11.3. okay, so 11.3 exercise containing questions related to plane. So we have to solve one by one. So first question is, in each of the following cases, determine the direction cosines of the normal to the plane and the distance from the origin. So here means there are given how many planes? 4 planes in one. So we have to find the direction cosines of the normal. Direction cosines of the normal and distance from origin. So that is related to normal form. There are 4 planes given, just like this. What? Z equals to 2, x plus y plus z equal to 1. Here z equals to 2. Second is given what? X plus y plus z equals to 1. I will discuss in short, just you have to write completely in detail. Okay. So third is given just like this. What? 2x plus 3y minus z equal to 5. 2x plus 3y minus z equals to 5. And fourth question is what? Fourth question, 5y plus 8 equals to 5y plus 8 equals to 0. These are the given equation of planes. We have to find direction cosines of normal to the plane and distance from the origin. So here direction cosine, that means we know the equation of plane, this is normal form and this is not normal form. This is not normal form, because in this equation normal form, in this equation d is the distance from origin. Here not. It can be it can be transferred to here. How? N cap unit vector along a normal direction. This is normal direction. If it is normal direction, then we can convert it by dividing it modulus of n cap. Modulus of n cap. Then this is constant value. This will be the d, and this is n cap. And n cap, if we have vector n cap, and its scalar component will be direction cosines. See here, no, general, this form is given. Okay, so for that, just we have to, this is in Cartesian form, okay, just like the format, this format, ax plus by plus cz is equals to d dash, this format. So for finding direction cosine, of normal, how can we find? A by root of summation a square. Summation a square means a square plus b square plus c square. Root over a square plus b square plus c square. A by b by root of summation a square. C by root of summation a square. And d dash by summation root of summation a square. This will be what? D. This will be L, M, N. Just we have all the equations given in this format. Okay? So here, it can be written how? 0 into x plus 0 into y plus g 1 into z equals to 2. That is, this can be transferred to normal form. How? Just divide it by root over a square plus b square plus c square. Just like this. Okay, this way, this plus this plus this plus this equals to this. So L is M, Lx plus My plus Nz equals to D. Okay, so if you convert this equation in terms of like this, Lx plus My plus Nz equals to D, then this is perpendicular distance from origin. This is L, M, N are direction cosines. So here 0 into x plus 0 into y plus 1 into z equals to 2 divided by what? Root over 0 square plus 0 square plus 1 square root over 0 square plus 1 square plus 0 square plus 1 square. So we see that root over 1. So 0 upon 1 into x, 0 upon 1 into y, 1 upon 1 into z, 2 upon 1. So this is Lx plus My plus Nz equals to D. That is L equals to 0, M equals to 0, N equals to 1, and D equals to 2. So direction cosines are direction cosines of normal to plane. Direction cosines of normal to plane. This is what? Distance from the origin. Distance from origin. Okay. So what are the distance? Here 0, 0, 1 and 2 units. Distance is 2 units. In a similar fashion you can solve all the questions. Okay. So here take second question, third question, fourth question, fifth question, you can write. Okay. So and one thing is important here that at the time of writing, just you have to write the right hand side as positive way. Here we can write x plus 1 y plus z equals to 1 root over 1 square plus 1 square plus 1 square root over 1 square plus 1 square plus 1 square. Here also root over 2 square plus 3 square plus minus 1 square root over 2 square plus 3 square plus minus 1 square. Here right hand side, so take constant on the right hand side, but as a positive value just write here minus 5. So it will divide 0 into x plus 0 into z, and here 0 into x. Okay, so divide by, it's divide 0 square plus minus 5 square plus 0 square, just like this. Same thing, divide by same thing, minus 5 square plus 0 square. Now you can write it. Okay, from here 1 by root 3, 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 11. 1 by root 3, distance. From here 2 square, 3 square, 9, 9 plus 4, 14, root 14. So 2 by root 14, 2 by root 14, 3 by root 14, and minus 1 by root 14, and here 5 by root 14. This is D, perpendicular distance. This is D, this is D, and this is LMN. This is LMN. Here also, what? 5 square, root 5. So 5. So 0, first 0, 0, minus 5 by 5, minus 5 by 5, and here 0, here 8 by 5. So L, M, N, this is D. Okay. So very simple. Just convert it by dividing of this. Okay. So remember that ax plus by plus cz is equals to d dash. If this is given, then just it can be converted as lx plus my plus nz equals to d by dividing it of root over a square plus b square plus c square, just like summation a square. A by this, b by this, c by this, 11, d by this, d. Okay, so you can get direction cosines and direction perpendicular distance from origin. So this question 1, this is the question 1. And second, find the vector equation of a plane which is at a distance of 7 units from the origin and normal to the vector this. Here not unit vector is given. This is L dot n vector is equals to here vector n is given. Okay, and distance is given from origin. Okay, vector equation of a plane which is at a distance of 7 units from the origin and normal to the vector 3, 5, minus 6. That is in question 2, or D is given. D is given as 7, but an n cap is not given. Okay, n vector n is given. Vector n is given. So we have to write vector equation. So here just like this, n is given 3i plus 5j minus 6k. This is given. Normal to the vector is given. that is vector n, not unit vector. And distance 7 unit from origin is given. So distance d is given here. Okay. This is given and this is given. Vector. So from here we have to find n cap. N vector upon n vector modulus. So n vector 3i plus 5j minus 6k upon modulus of this means root over 3a square plus 5a square plus minus 6 square means what? 9, 25. So 3i plus 5j minus 6k upon root of 70. Root 70. 9, 70. Okay, this is unit vector. Therefore, the required equation of plane is given by. Now we know here what? Distance from origin is this, and this is normal to the plane. So in this direction, unit vector is this. So r dot n cap equals to d. That is, r means r dot n cap. Just you have to write 7. That is 3i plus 5j minus 6k upon the root of 70. So this is our vector equation. Clear? So vector equation 11.3. You can see 11.3. Okay, so this is our answer. Vector form. Clear? Now question third. Question third is what? Here. Find the Cartesian equation of the following planes. These are given in vector form. So just we have to write only Cartesian form. Cartesian form written is very simple. So third question first. How can we write Cartesian form of equation of plane from vector form? Here, question 3. The first question is, there are 3 questions I think. Okay, so r dot this equal to 2, r dot this equals to 1, r dot this equals to 50. So here, first is r dot I plus j minus k equals to 2. I plus j minus 2 equals to 2. I plus j minus k equals to, minus k equals to 2. These are the unit vector, no? This. First is this. Second is also this type of similarly. Second, what? R dot 2 I plus 3j, 2i plus 3j minus 4k equals to 1. And third is given r vector r dot s minus 2t, 3 minus t, s minus 2t. This is a constant involving constant only, nothing more here. 3 minus t and 2s plus t, 2s plus t k is equals to 50. Okay, this type of 3 equations, just we have to find Cartesian. This is vector, just write, put what? It's Cartesian in terms of component form, xi plus yj plus zk. This is arbitrary vector in above, in the given equation. Just we get xi plus yj plus zk dot I plus j minus k is equals to 2. Just we get what? Dot product. This dot this. I1 x plus y minus z equals to 2. So this is our solution. Simple. Similarly here, what will be the solution? xi, yj, zk, 2x plus 3j, y minus 4, z equals to 1. This. Here, this is constant. No? S minus 2t into x plus 3 minus t into y plus 2s plus t into z equals to 50. So this is solution. Okay. Fourth question is, in the following case, find the coordinate of foot of the perpendicular drawn from the origin. So, just I will discuss about on the remaining questions in next class with some new theory. Okay, theoretical part. Just you have to solve all these questions and formulas. Note down all formulas in your copy and send me PDF file for your attendance. Okay.